Using the limit of the Riemann sum, find the integral of 1 to 5 3x dx. We will be using the two equations to help us that you see at the top of the page. So first, to start, we have to find delta x. We know our b and our a, but we don't know our n. So therefore, we have to do 5 minus 1 over n. So our delta x is 4 over n. Next, as you can see, if you look at the area of the limit equation at the top of the page, we need ci. So the equation for ci is a plus I delta x. So our a is 1, and then the delta x that we just solved for is 4n. So our ci equation is 1 plus I 4n. So after we get our ci, we have to plug it back into the function, which is 3x. So when we multiply 3 times ci, we get 3 plus 12 over ni. Next, using the equation at the very top of the page, we can plug everything in, and we get n sigma I equals 1 times 4n, which is our delta x, times f of ci, which is 3 plus 12 over ni. After you multiply the 4n times ci, you get 12 over n plus 48n squared I, which we can then separate into two separate things, and you get n sigma I equals 1, 12 over n, plus n sigma I equals 1, 48 over n squared I. Then when we separate the two, and we look at the first one, which is 12 over n, we can pull the 12 over n out and take that on the other side of the sigma, and we're just left with the 1. And 1 equals n. So therefore we have 12 over n times n, and the two n's cancel out, so we just get 12. For the other part, we have 48n squared times I. So to do that, we have to take the I and separate it from the 48 over n squared, and we use the I equation at the very top of the page. So we have 48 over n squared times n parentheses n plus 1 close parentheses over 2. And then once you simplify that, you get 24 parentheses n plus 1 close parentheses over n. Once you put those two pieces together, you get 12 plus 24n plus 24 over n, which you can further then simplify to 12 plus 24n over n plus 24 over n. And then in the middle 24n over n, you can cancel out the n's. And then we're left with the limit as n approaches infinity, 36, because 12 plus 24 is 36, plus 12 over n. And then we can cancel out that final 24 over n, because n equals infinity, and a number divided by infinity is so small that it's considered insignificant. So the answer to this problem is 36.